Okay, in this video we'll be looking at the relationship between longitude and time. So hopefully you're aware that what causes day and night, so our conception of time, is the rotation of the Earth. So if the sun's to the left here, in this awfully out of scale illustration, then anywhere on the left facing the sun would currently be in daytime. And anywhere on the other side of the Earth facing away from the sun would currently be in nighttime. So it's clear that only your position in the east-west sort of horizontal direction has any effect on whether you're on the bright or dark side of the world, which means that only the longitude controls time. Now, each full rotation of the Earth corresponds to what we call one day. I'm sure you know that. And that is roughly 24 hours. Now, that's not exact, but in our course, we will pretend it's exactly 24 hours. So that means when the Earth does one full 360 degrees spin like that, we'd say that 24 hours has passed. And it'll be helpful to note very soon that multiplying this number by 60 tells us that this is equivalent to 1,440 minutes. Okay, what we want to do now is to see what approximate time difference each degree of angle makes here. Okay, so because all 360 degrees should be about 1,440 minutes, then each degree should be worth 1,440 minutes divided by 360, which ends up being about 4 minutes. So it's helpful to know that each degree of longitude, and only the longitude, is worth around 4 minutes. Latitude has no effect whatsoever on time. Okay, so let's try and use this idea to solve an example problem here. There's a football game scheduled to begin at 7 p.m. in a city in Spain, located at 43 degrees north and 3 degrees west. We are watching the game from home, which is 34 degrees south and 151 degrees east, and we want to know what time the game starts in our clock on our side of the world. So first, remember only the longitude matters. So we only care that the game is happening at 3 degrees west, and we live at 151 degrees east. Right? We completely ignore the latitude. Now, how I like to do these is by just sketching a rough timeline like this. Now, of course, it's meant to be round, but I'm pretending this is like a piece of paper, and this is something you can actually draw when doing your own work, okay? So we treat west as left and east as right, as normal. Now, the game happens at 3 degrees west. We live 151 degrees east, so that means the difference in longitude is a total of 154 degrees. And to turn this into a time difference, we had before that each of these degrees is worth 4 minutes, so we need to multiply this number by 4, and we get 616 minutes. It'd be easiest to turn this back into hours and minutes, so 600 minutes is of course 10 hours, and then we have the extra 16 minutes as well. Okay, so we know that the game starts in their local time of 7 p.m, so that's the time at B. Then, since we are to the east, to the right of this point, what we need to do is push our clock forward. So it's just like a number line. Right is going forward, left is going backward. So you'd be rewinding your clock if you had to travel to the left. Okay, but we're traveling right, so we're going to push our clock forward. Now, there are many ways of thinking about how to do this easily, but often with clocks, thinking in 12s is convenient. We know that pushing forward 12 hours takes us straight to 7 a.m. the next morning. That'd be around here. But because we only wanted to go 10 hours, we'd rewind that back 2 hours to 5 a.m. in the morning. Okay, so some people like to think like this. I often just picture a clock. I don't know how you think about this easily, but in any case, it's 5 a.m. When we go 10 hours ahead. Okay, but finally, don't forget the 16 extra minutes there. So that puts us to 5:16 a.m. Okay, and it's actually the next day. Okay, because we've passed the midnight mark. So some questions may also ask you for the day of the week, or maybe the date, or something like that. Okay, so in that case, you would really need to be aware that we've crossed over to the next day in Sydney time. So this is one way to roughly handle time differences purely using longitude. Okay, but commonly we don't actually do this in real life. Next time we'll look more at how it's actually done, which is using something called time zones, but that is all for this one, so see you around.